Hello and welcome to the first video of Math 050. This is what your notes are going to look like. We kind of did that little practice on the syllabus video of how to take notes. So, what I want you guys to do is to make sure that you have this sheet out and that you have a pencil ready to write down everything that I'm going to write down. Okay, so I'm going to go through this pretty slowly, and at the end of the video, we'll kind of talk about how to do homework and how to, check your homework. Okay, so, we'll go through that. So let's just go ahead and jump right in here. And let's talk about the objectives real quick, what you'll be able to do by the end of watching this video and after doing the homework. And so what we want to do is we want to state the integer that corresponds to a real-world situation. We want to be able to graph rational numbers on a number line. This is really important. We want to be able to convert from fraction notation for a rational number to a decimal notation. Determine which two real numbers is greater and indicate which by using these inequality symbols. And determine whether those are true or false, and then we'll find an absolute value of a number. Okay, so first thing we got to do, we have a couple of these words here, like integer, rational number, real number, okay? And I want to go through what the different types of numbers that we have, okay? So what I want to do, I'm going to zoom in here pretty far, and I'm going to start writing, and I'm going to do this. So let's do, I want you guys to write down the word in the middle of the page, natural numbers. Okay, and I'm going to use the hashtag symbol for numbers, so I don't have to write out numbers every time. So the natural numbers, and I'm going to call these the counting numbers. Okay, and what that means is that I have the numbers like 1, 2, 3, 4, 5, 6, and so on. Okay, those are what we call the natural numbers. The natural numbers are counting numbers starting with 1. Okay, and that's the important thing. Okay, now, if I were to say, all right, well, that's all fine and good, but what else could we add to that? Okay, what other number could we add to this to kind of expand this group of numbers? And what I would say is I would then say that we have what's called the whole numbers. So let me come in here, and this is the whole numbers. Okay. The whole numbers are the natural numbers, so all of your counting numbers like 1, 2, 3, 4, 5, 6, and so on, but we include 0. So I'm going to write this, that this is the counting numbers, and 0. Okay, and so if I were to describe that, I would say that this set of numbers would be 0, 1, 2, 3, 4, these are commas, not periods, 5, 6, and so on, okay? But the difference is that if you were to say a whole number, you would have to include the number 0, okay? Now, the whole number includes the natural number, so I'm making this kind of like a web diagram where, the whole numbers are inside of this big group of numbers, okay? And it includes the natural numbers, all right? But not every natural number is a whole number, and the only number that is 0, okay? Moving on, let's talk about another one, and that would be the word integer, okay? All right, so the word integer means an integer is the whole numbers, so the whole numbers, and their opposites, so the negative numbers, okay? So what I would do is I would say this includes the numbers like -3, -2, -1, 0, 1, 2, and 3. So an integer contains all of these numbers. It contains the whole numbers and the counting numbers and the natural numbers, but it also contains the negative numbers as well. Okay. The next one that we have, and let me zoom out and see how much room we have here. Okay. And let's write this over here. The next numbers that we have that we're going to talk about quite a bit are the rational numbers. Okay, so rational numbers, okay? And these are what we call, rational is kind of the same thing as fractions, okay? And we're going to kind of talk about the differences between fractions and decimals and how they're the same and how they're different. But they're fractions, so fractions whose decimals either repeat or terminate. Okay, and so an example of this would be something like, say, 1/2. Okay, the decimal approximation with 1/2 would be 0.5. Okay, and we'll talk about how we actually get those numbers. But see how this decimal just stops at 0.5? There's no other numbers to the right of it. Okay, that's an example of that. You know, if you wanted something that repeats, let's look at the number like 1/3. Okay, that decimal would be 0.3, and that repeats, okay? And so you would also just call it like 0.3 repeating, okay? And so when you have 1/3, okay, this number keeps going, and you keep getting threes, okay? These are all rational numbers, okay? And even if you had, you know, the rational numbers include all of the integers and whole numbers and natural numbers as well. What you have is you have this concept of say, like, let's say you have like the number 5, okay? Well, that itself is a fraction, okay? You're taking 5 and you're dividing it by 1, okay, which just gives you 5.0, okay? So this decimal terminates, this decimal stops, okay? And that's the idea, all right? So that's what a rational number is, okay? And then the last one that we have, let me draw a box around this. So a rational number contains all of these different numbers here, okay? The next set of numbers that we have is the real number system, okay? So the real numbers, okay, include the rational numbers, the integers, the whole numbers, the natural numbers, but the real numbers are any number on the number line, okay? And so that would include any single number that you could ever conceivably think of, okay? And so what I do also want to talk about real quick is that includes the real number system. Well, hold on. So let's do this. Let's draw a box around the real numbers. All right. And I'm going to leave some space over here, okay? So the one thing I want to do here for the real numbers is I want to draw a number line. Okay, and a number line is just a horizontal line like this, where I put, you know, 0 typically in the middle, and, you know, you can put like any number here, like 1, or you could put like 1.374, okay, where over here you could put like negative 2.1657, okay, and so on, all right? So these are real numbers. Any number that you could conceivably think of goes here. Okay, so there's kind of a little caveat here. We also have, you know, a part of the real number system that isn't a part of the other number systems is the concept of a irrational number. Okay, so I'm going to come over here and I'm going to write over here irrational. All right, and it's the opposite of a rational number. So irrational number is something whose decimal doesn't repeat or terminate. All right, and so an example of that number would be the number pi. Okay, we think of pi as approximately 3.14, but actually this number, this decimal, goes on forever and ever and ever, and it doesn't stop, okay? So 3.141592 and so on. So the decimal approximation is random, okay, random numbers, and it doesn't end, okay? And there's quite a few numbers like that that we'll kind of explore, but that's the only example I'm going to give you at this point. But that's its own like separate number group. So all I'm doing right now, guys, is I'm just writing down the different types of numbers, okay? So when we talk about, state the integer that corresponds with the real world situation, we want to know what an integer is. Okay, when it says convert from fraction notation to for a rational number, we need to know what a rational number is, okay? And then find the absolute value of a real number. We need to understand what a real number is. So a lot of what this is just vocabulary, okay? And I know it's kind of tedious, I know it's kind of annoying, but it is really important to go over this so that if I say, if you see in the book or somewhere something that says an integer, well, we need to understand that an integer is what it is. Okay, so you do need to know what all of these things are. Okay, so hopefully you wrote all that stuff down. And if you need to write down other things that I said, go ahead, feel free to pause the video, go back and look at those to see if there's any other notes that you need to write down. Okay, I'm going to try and write down everything that I can that's important, but we'll just go from there. Okay. So then the other thing I want us to be able to do, that we're asking you to do in this section, is to graph a number, graphing rational numbers on a number line. Okay, so both of these are rational numbers, -7/2 and 1.4. And we're going to go through in a second to show how we get the decimal approximation of this. -7/2, what the value of that number is in decimal notation to kind of figure out what that is going to be -3.5. Okay, and we'll talk about how I get that. Some of these things I can do in my head, but there's an actual way to do it either on the calculator or by hand to figure out what that is. So what we want to do is we want to figure out where's that number at on this graph here. Okay, so we have this number line here, and one thing I want to talk about first is that the numbers. First, we want to locate where 0 is. Okay, 0 is right here in the middle. Okay, if we go to the right, these numbers are positive. Okay. And that means that they're big numbers. Okay, the further to the right you go, the bigger you get. Similarly, over here on the left side, if the numbers over here are negative, okay, they're opposite, and these get smaller. All right. So if we wanted to locate where -3.5 is, what I want to do is I want to start at 0 and say, okay, first of all, it's a negative number, so I'm going to go to my left. And if I go over to the left 1, okay, then I go 2, and then I go 3. Well, 3.5 is in between 3 and 4, and if it's negative, it's going to be in between -3 and -4. So that number is going to go right here, and I'm just going to call that -7/2. Okay? So for me to do it, I have to kind of convert that into a decimal. Okay? I kind of know where it is because I've done math for a long time, and I just know what that number is, but for your purposes, turn it into a decimal, okay, and go from there. All right? Okay, on the next one, let's do another example where it says 1.4. Okay, same thing. 1.4 is a positive number. It's going to be in between 1 and 2, a little bit closer to 1, so, just guesstimate. Doesn't have to be perfect, but I just want you to plot that number right there. And then I put an arrow to it and I say, well, 1.4 exists right there, okay? And that's where we've got it. All right, so that's one thing that we want you to be able to do is just plot those numbers on a number line, okay? The next thing I want you to do is to be able to convert this fraction into a decimal. Okay, now we have the value of -5/8, and we're going to talk all about, negative numbers, how to operate within negative numbers. But for right now, our answer is going to be negative. So the first thing I want to do here on this one is that if we're converting it to a decimal, if it's already negative, then the answer is going to be negative. Okay. Now, what I'm doing here, when you have a fraction, okay, is you're taking this number 5 and you're dividing it by 8. So this symbol here, when you have a fraction, there's an operation you're doing. You're doing division. Okay. And, one way that we can do this is, sorry, let me finish writing that out. One thing that we can do when you're converting to decimal notation is you can use a calculator, and you can just take 5 and divide it by 8 in your calculator and get an answer. Okay, but I'm going to show you how to do this by hand. Now, one thing I want to talk about with your calculator is your calculator should be used to check your work, to not actually do, to not actually have do all the work for you, because you want to be able to have a sense of what your answer is going to be, kind of the value of that number, but you want to be able to do it by hand and know how to do it by hand in case you don't have a calculator someday. Okay, your calculator is a tool; it's not your brain. Okay, so, you know, you can do the math, you can figure out what this is in decimal notation, it's not that hard, but we want to be able to do it by hand. So first of all, let's do this. To do 5 divided by 8, okay, it's going to give us a decimal. Let's do this, okay? Let's do some long division here, and I'm going to write it as such. I'm going to go, if we're doing 5 divided by 8, I'm going to do 5 divided by 8. Okay, now because the problem is that, you know, when your divisor is 8, you are going to, since this number is larger than 5, okay, what I want to do, I know I'm going to get a decimal out of this. I'm going to put a placeholder here, I'm going to put a decimal, and then I'm going to put zeros to the right of that decimal, okay? Because, and the reason why is because when I ask the question, okay, how many times does 8 go into 5? Well, 8 doesn't go into 5, okay? 8 is larger than 5, okay? But I asked the question, okay, well, what about 8? How many times does 8 go into 50, okay? And I kind of ignore this decimal for a second, and I just use that decimal as a placeholder. I'm going to put that up here in my quotient as well, okay? So 8 goes into 50, that would be what, 6? 6 times? So I'm going to put a 6 up here, okay? And the reason why I did that is because I was like, well, you know, again, 8 doesn't go into 5, but if I move this over and think of 50, well, 8 does go into 50, okay? So I know it goes in there 6 times. And what I'm going to get, if I do 6 times 8, is I'm going to get 48. Now I'm just going to keep my decimal below that, and I'm going to put 4 and an 8 here. Okay, so 6 times 8 gives me 48, or 0.6 times 8 gives me 4.8. Now what I do is I'm going to subtract, and I got 50 minus 48, which is going to give me 2. And I got to keep my decimal placeholder here, and gives me 0.2. Okay, and then I redo that process, and I say, okay, 8 goes into 2 how many times? Well, that doesn't work. 8 doesn't go into 2 because 8's bigger than 2, but I'm going to drop down this 0 here and put that there. And then I go back and I do the same thing again, and I say, okay, well, how many times does 8 go into 20? And the answer to that is going to give me 2. Okay, it goes into it twice. If I do 2 times 8, that's going to give me 16. So I need to keep my decimal place here. I'm going to put a 16 here, and then I'm going to subtract. Okay, so if I do 20 minus 16, that's going to give me 4. Okay, I'm going to keep the decimal there and put a 0 and a 4. And then I repeat the process, and I go, okay, how many times does 8 go into 4? And the answer to that question, again, I can't do that, so I have to, you know, drop down the other placeholder here for the 0. Okay, and so then I ask myself, okay, how many times does 8 go into 40? Okay, I look at these numbers here. I kind of ignore this 0. And then I say, okay, 8 goes into 40 5 times, okay, because 5 times 8 is going to give me 40. So 5 times 8 gives me 40, so 0.040, subtract over, and I get a remainder of 0. So once you get to this point where you get a 0 down here, you're done, okay? This means that you're done, all right? And so your answer, this is your decimal, okay? And what I encourage you guys to do is it's really easy to just go, okay, well, what's 5 divided by 8? And you just type that into the calculator, and you're going to get 0.625, but you should also be able to do it by hand, okay? And I would check with your calculator, because I'll be honest with you, I've made like 3 mistakes while doing this problem, okay? Long division can be kind of tricky, but at the same time, you guys also need to be able to look at this and just say, all right, does this make sense? 5 divided by 8, do that in your calculator, and then, work towards your answer. And that's something that we're going to talk about with your homework solutions, okay? So the answer here, if I do negative 5 divided by 8, that's going to give me negative 0.625. You could also rewrite this as negative 0.625. It doesn't really matter. Either of those would be fine, okay? All right, let's take a look at the next one. Convert this into decimal notation. Okay, and 7 divided by 11, I don't really know. Okay, so I don't know what that is. I don't know the decimal approximation. You can, I would advise to use your calculator. And let's just go ahead and do that real quick. And when I put that in the calculator, what I'm going to get is 7 elevenths is going to give me 0.63 repeating. Okay, and I'll talk about how I know that that's repeating on the calculator and how, we'll go through this using long division to show that. Okay, so what I'm going to do is I'm going to take 7 and I'm going to divide it by 11. Now, because 11 is larger than 7, I need to put placeholders here. I need to put a point and then 0, 0, 0, 0, 0. So, don't need too many, but 5 would be sufficient. Okay, so if I were to say this, how many times does 11 go into 7? It doesn't. 11 is larger than 7. But how many times does 11 go into 70? And another question that you could ask is, 11 times what gets me either 70 or gets me really close to 70? Okay, and the answer to that would be 6. Okay, 11 times 6 gives me 66, which is pretty close to 70. So I'm going to do this. I'm going to put a decimal place up here. I'm going to put a 6 there. So 6 times 11 is 66, so 6.6. All right, and keep that line of your decimal going up and down, okay? And then what I'm going to do is I'm going to subtract these, and I say, okay, I'm going to get 70 minus 6.6, or 70 minus 66 is going to give me 0.4, okay? So then I repeat that process, and I say, okay, 11 times what is going to get me close to 4? All right, well, that doesn't work because 11 is larger than 4, so let's do... let's drop down this 0 here. Okay, what about 11 times what gets me close to 40? And the only one that gets me close is 3. Okay, 3 times 11, and I put that up there, 3 times 11 is going to give me 33. So I'm going to put a 0.33 down here. Okay, and then I'm going to subtract, and if I do 40 minus 33, that's going to give me 0.0, and then I'm going to put a 7 there. Okay, and we're kind of back to where we started up here. Okay, so let's try this again. Let's see, and I always just kind of keep doing division until I notice a pattern. And so the one thing I want to do is I want to drop down this 0 again to give me 70. And then I ask the question, okay, 11 times what gives me close to 70? And that number is going to give me 6. Okay, so 6 times 11 is going to give me 66. All right, make sure you keep all your placeholders intact, and then go ahead and subtract these numbers, and that's going to give you 0.004. Okay, let me drop down this 0 again over here, and I ask the same question. 11 goes into 40 how many times? It goes in 3 times. All right, and what I notice is that I keep getting 6 and 3 again. So if I do this process again, 3 times 11, 0.0033, and then subtract, then I'm going to get 0.0007 out of that. And we keep going over this process. If we keep doing division, we're going to keep getting these numbers, 0.6363636363, and that's going to go on forever. So I could write 636363. Okay, and it's just going to repeat. So because it repeats those numbers 63 every time, if I take 7 and divide it by 11, it's going to give me 0.63 repeating. I don't need to write out 636363 until I get to infinity. I just need to write out 63, put a line over it, and that indicates that it repeats. Okay, so let's go ahead and let's move on to the next page and kind of finish up this section. I know I'm kind of going slow, but I just want to make sure that we know how to do this, all right? Okay, the next thing we need to talk about is order of numbers. And we say that real numbers are named in order on a number line, okay, and that we increase as we move to the left, from the left to the right for any two numbers in the number line. The one on the left is less than the one on the right. Okay, so let's just kind of talk about this for a second. Let's just draw a quick little number line here, and I'm going to put 0 here in the middle, all right? The numbers over here are positive, and these numbers are big, okay? I'm going to put a negative sign over here to the left, and these numbers are going to be small. So in order to order numbers and say, okay, which number is bigger than the other, we need to kind of think of a number line, okay? And so what I'm going to do here for all these different examples, we want to classify these as either less than or greater than to write a true sentence. So what I want to know is which number is larger? Is 2 larger than 9, or is 9 larger than 2? And the answer to that question, obviously, is 9 is larger than 2. Okay, and that should be pretty easy for us. But what I want to do, in order to show that 9 is larger than 2, I need to put this symbol in here, okay? And what that means, and however you want to choose it, you know, when I was younger, we used to think of this as like a Pac-Man, okay? And that the Pac-Man is going to eat the bigger number, and you think of this as like a little mouth, okay? I like to think of some people think of like an alligator, but I like to think of a shark. I'm really into the movie Jaws. So if I have that little symbol there, you know what I think of. I draw a little shark, and the shark is going to eat the larger number, okay? And I draw it as such, okay? There's my little shark. Okay, so the shark's going to eat the bigger number. So we just want to know which one's bigger, and we do that, all right? So, and we can also think about this on a number line, okay? If I were to graph, you know, put 0 here, you know, locate 2 on that number line and locate 9, 9 is furthest to the right, okay? This is big, this is small, okay? So 9 is bigger. Okay, now what about this? What if you had, like, say, -7 and then 3, okay? This is where it gets a little weird, okay? -7, you know, you would think that like maybe -7 is larger. Actually, 3 is larger than -7. And the reason why is because if I were to plot these on a number line, here's 0, here's 3, -7 would be over here. Okay, 3 is bigger. It's furthest to the right. Okay, so not too bad. Okay, now let's take a look at the next one. -6 and then -12. This is actually going to give me that 6 is larger. Okay, and so I'd have the symbol eating the 6. All right, so over here, let's think about this. All right, let's put a 0 in here. Let's put a 6 down, and let's put a -12. And guys, I'm not being very exact when I draw these number lines. I'm just kind of doing it as a point of reference, okay? And so the 6 is further to the right. It's positive, all right? So let's circle that. I'm going to put that as big, okay? -12 is small. Okay, now this is where the problem gets, and make sure you pay attention during this part, because if we're comparing the value of -18 to -5, a lot of times you're going to assume that -18 is larger, but it's actually not. -5 is a larger number in this case. This is where it gets kind of weird. All right, let's draw a number line, okay? Both of these numbers are negative, so they're going to be left of the 0. So here's 0. I'm going to put -5 here, and I'm going to put -18 over here. Okay, -5 is further to the right than -18. Okay, this number is bigger. Okay, if you're on the right side of the number line, you're big. Okay, if you're on the left side, you're small. Okay, and that's how it works. Okay, so if you need to draw a number line to analyze which number is bigger or smaller, then do that. Okay. All right, now the other thing that we can do is I can sit here and I don't have to write this statement as -3 is greater than -8. Okay, I could also say here and rewrite it, same thing, and switch these numbers up and say that -8 is less than -3. Okay, I can rewrite this however I want, as long as it's true, as long as I look at it and say, all right, well, -3 is larger than -8. And let's just go ahead and draw a number line again and put that down. Let me put a 0 here, let me put a -3 here, let me put a -8 over here. Okay, -3 is further to the right, meaning it's big. Okay, so I wanted to show this example again to show that you don't have to always write it in a certain way. When you write inequalities, you can write it however you want, all right, as long as you write a true statement. Okay, so let's kind of analyze with some of these true statements, okay? So what I want to do is go through and say, okay, I have this statement that -3 is less than or equal to 5.4. Now, is that a true statement? Is 5.4 at least larger than or equal to -3? So let's just draw a number line real quick and verify. Okay, and so I've got, let me put a 0 here, let me put a -3 here, and let me put 5.4 right here. Okay, 5.4 is to the right of the number of -3. Okay, so it's going to be bigger. Okay, and if the shark is eating the bigger number, then then we're good. Okay, so if it's eating the larger number, then it's a true statement. Okay, you don't need to draw the shark. If you want to, you can, but you don't have to. Okay, on this one, it says, okay, -5 is greater than or equal to 1 2/3. Okay, 1 2/3 as a decimal, if you wanted to put that into a decimal, what you would do is you would just take 1 point and then 2/3, that's just going to give you 0.6 repeating, so 1.6 repeating. Or you could just do that division on your, do long division. Okay, so if you're having trouble with that and knowing what 1 2/3 is, put it in a decimal form. Okay, all right, so let's just draw a number line here. Okay, and we end up having, let me put my 0 down, let me put 1.6 repeating here, and then let me put -5 over here. What I notice is that 1.6 is to the right, meaning that we're big. Okay, but this is saying that -5 is big, so this is false. No, doesn't work. Okay, don't do it. It's false. Okay, all right, moving on. Take a look. Oh, that's it. Okay. All right, let's talk about what absolute value is. Okay, now absolute value means distance from 0. Okay, distance from 0. Distance from 0. Okay, and what I know about this, distance from 0 is always positive. Okay, always positive. All right, so if we were to draw a number line here, and let's just analyze the number 4 and -4. Okay, here's 0, and let me put 4 here, and let me put -4 here. Okay, if I were to find the absolute value, and let me do this, absolute value of 4. Okay, what's the distance between 4 and 0? All right, and that distance is going to be 4. So the absolute value of 4 is equal to 4. If I were to take the absolute value of -4, what's the distance from -4 to 0? And that distance, because distance is always positive, is going to be 4. So if I were to take -4, absolute value of -4, I'm going to get 4. So the rule of thumb is that if you have these two like sideways numbers, like kind of like parentheses, like straight up and down parentheses outside of a number, you just take whatever's inside that number and you just make it positive. Okay, so let's kind of take a look here. Find the absolute value of -7. If you want to, you can draw a number line. Okay, and you can write this down and you can say, all right, here's 0, here's -7. Okay, what's the distance between -7 and 0? And that value is 7. Or you could just think, whatever's inside of my inside of these absolute value symbols, make it positive. And you're 7, and that's it. Okay, so if you want to draw the number line, you can. If you want to ask yourself that question, that's great, but you don't have to always. Okay, by definition, that's what it is. Okay, the absolute value of -2.73, let's just take what's inside, make it positive. So we've just got 2.73, and we're done. Okay, pretty easy. The next one, absolute value of 12. What's the distance between 12 and 0? That's just going to be 12. Okay, so if it's already positive, just keep it as positive. Okay, and that's it. All right, so what I'm going to do, typically what I'll do is the video would be done at this point. Okay, I do want to talk about your homework and what's available to you on your homework. Okay, so your homework, 7.2 homework, would be 7 through 67 every other odd. So you would do like, say like 7, and then you would skip over the next odd. The next odd number would be 9, but then so the next one you would do would be 11. Okay, and then the next one you would do would be 15, and so on. So every other odd, starting with 7. Okay, and that's yay. Even this. Understanding what this means, hey guys, that's a little bit of math. Okay, figuring out what problems you have to do. Okay, let's take a look at the next page and kind of talk about how to do your homework. Okay, so available to you guys on the internet and on Canvas is going to be these homework solutions. Okay, so what I have done is I have actually done the homework for all of your homework problems. Okay. And so it took me a little bit of time, but I want you to have this information. Now, a lot of times I don't write down like the problem that you see. I just write down, okay, here's the number. This is one of those examples where we did a problem where we located a number on a number line, and that's all I did. Okay, and kind of drew my own number line and did that. So, let's think of the point of this. Okay, the point of this, of having these solutions, and why I did all of the homework for you, is for you to check your homework. All right? It's not for you to sit there and copy. If you sit there and copy, it's not going to work. Okay? What you'll end up doing, you're not going to learn anything. You're just going to copy it down and get points. But you remember how much your homework grade is. Your homework grade isn't that much. Okay? Your grades really come from your exam. So, the question is going, okay, how did, when you're looking at this, and let's say you start this out, you watch the video, you get your homework out, and you look at number 7, and you say, okay, 10/3. How did he know to put 10/3 between 3 and 4? Okay, you should be asking questions. Ask why. Ask why police did this. All right, ask why did what he did. Ask why police did what he did. Okay, and so something like this where, all right, what did he do? He did 5 and 6. Okay, so the 6 goes down here, the 5 goes here. He put these extra zeros in here. He did this. Wait, how did he get 8? Okay, where does the 8 come from? 8 times 6 gives me 48. And then, how did he go from 48? How did he get this 2? What operation did he do? And maybe you notice this subtraction symbol down there. So, this is kind of like this concept of like reverse engineering. If we obtain some sort of technology from something else, and we want to figure out how it works, you have to ask questions, okay? Ask why police did what he did, okay? And what I would do, guys, is I would try the problem first. Whenever you're doing homework, I would try on your own. Okay, try on your own, and then check your homework. Okay, but try on your own first. Okay, and if you have no idea what to do, then go back through and try and figure it out. Okay, and also use the videos as well. But I have this information available to you. First, I wanted to do it so that I knew exactly what I needed to teach you. Okay, that was the first thing. But the second thing that I did is I want you to have this because when I was your age, or when I was going through classes, I had a hard time like understanding it from reading the book. But if I had every problem worked out the way that a teacher would do it, I could actually go through the steps and go, okay, how did they go from one step to the next? So you have to ask, why did the teacher or why did the person do what he did, or he or she did, okay? And that's really important that you're able to do that, okay? All of these homework assignments will be available to you, but I want you to use them as a tool, okay? Much like your calculator, okay? So to have these solutions available to you is pretty nice, that they're all worked out in the way that I would do them. Sometimes I skip a few steps here and there, but and that's the thing where, if you have a question and you're like, hey, wait a second, how come I can write it like this? How come -6 is greater than x, but x is also less than -6? Like, why did you write it both ways? So if you have questions, then ask questions, guys, please. All right, and ask what symbols mean. Ask what certain vocab words mean. If I don't explain it very well, then please, please, please ask me questions, all right? So hopefully this video is pretty informative for you. I wanted to show you, how I have this, that you have this information available to you. And here's the other thing. To turn this in, what I did was I took a picture of this, and I used a scanner app on my phone, and I turned this into a PDF and just emailed it to myself and was able to name it whatever I did. And I want you to be able to do the same. When you hand in homework, try and find some sort of PDF scanner on your phone that's free to send it to me. If you want to send me a picture, that's fine, but I prefer a PDF so I can save it and have that information for you, okay? And the other cool thing is that if you send me a PDF, guys, I can put it into this program and I can write on top of it and show you, where you're making mistakes and all that. So I will grade a fair number of problems on this, but, just a few. Like I would maybe grade like 19, okay? And I would go through and, on your page, if I saw that you had done this work, okay, I'll give you credit, okay? But if you just write out this information, 2/3 is equal to 0.6 repeating, I'm not going to give you all the credit. I would say, all right, how did you get that? All right, how would you do that? And so the other part of this class is that you'll have to, send me a video. I'll choose a problem for you guys to do where you have to actually show me the steps on how to do that. And you kind of got to do a video about how we get that. All right. So, I'll send out another video about some ways to do that. But, so far right now, I want you to just watch the videos for this, so far for this week, watch the videos, go through. I know this video is really long. I'm trying to make them as short as possible, but, right now at this point, because we're so early in the semester, I want to make sure that you guys are crystal clear on how you're using the resources and how you're using the notes. Remember, if you need to pause and rewind, go ahead and do that. All right. So you guys doing a great job. I look to hear from you soon, and good luck. See you in a bit. Thanks. Bye.